Hey everybody, this is Larry. This is me going Q3 of the weekly contest 435 minimum increments for target multiples in an array. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. I'm not gonna lie, I cheated on this one, and I'll tell you what I mean. But the core idea of this is brute force, and what I mean by that is just taking advantage of the fact that the number of target numbers is 4, right? So what does that mean to have a target number thing is 4? Maybe you see my cheating thing right here. What do I mean by target number is 4? Well, 4 means that we can brute force on some idea of combining things to kind of merge, right? So what that means is that, for at least for me, I mean, I know there's some stuff with bell numbers and stuff, and maybe you can even optimize a little bit, but for me, it's just 4 factorial times 2 to the 3rd power, right? And what does that mean? That means that for 4 elements, we just do all the permutations. So, you know, like ABCD, ABDC, ACBD, ACDB, dot, right? So 4 factorial, right? And then for each of these, we have 2 to the 3 spaces, right? So ABCD, you have 2 to 3 spaces, which you can, in a way, put in the delimiters, right? So you have that where they're all individual, or you could have like, I guess maybe all individual is actually something like this where they're all separate. But then, yeah, you can have something like that, and then, you know, so forth. I don't know. I mean, yeah. I mean, and that's 2 to the 3rd because the 3 things inside, and the 2 ways to do it, right? So that's basically the core idea of when I saw T is equal to 4, I was just like, maybe I can do something like this. I definitely made a lot of silly mistakes anyway, but did I get wrong answer on this one? Oh, I got 2 wrong. Yeah, because I just had some silly typos, but yeah, but basically that's the idea. And then now, what do I do with these groups? So if these groups, I actually did this in a way, not great way, but I just thought that, okay, let's say we look at one of this, let's say we have this, and that means that, okay, we want the LCM of A, B, and C, and then we also want to find D. So we're trying to find answer for this, and if you want to be precise, maybe just D, which is trivially true to D, right? And why do, and that's basically the idea. And we do brute force on all of them, then it should give, right? It's the idea. The reason why I did it this way with brute force, honestly, is because I don't have to prove it. Right? Well, not that I don't have to prove it, because we tried literally everything. Then you don't have to prove because you tried literally everything. It's the general idea. Because then here you try all combinations of numbers and the LCM with the answer. Okay, so I'm gonna go over my code real quick at this point, and then we'll do a live couple of minutes to figure out a better way, right? Which I been made aware a little bit. But yeah, so basically this is the way that I wrote it, though. I guess this, yeah, yeah. So for the target, I set up a permutation, right? So this is the 4 factorial part. This is the 2 to the t minus 1 that I say n here. T minus 1 for the number of spaces, so 2 to that. And this is to construct the array, right? So here, and you know, the numbers don't matter, whatever, or the bits don't matter, but it's just to enumerate all of them, which is that either we have a new number or we LCM it with the previous number to construct an array. And I just kind of did this to kind of like it's not quite memorization, but there could be duplicates, and if there are duplicates, then we just don't do them. It's just the nature of these things, because we don't have to do them. So I don't know if this is necessary per se, but it just saves time. And otherwise, we do a calculation, right? As we talked about with the brute force. And how do we actually do the matching? Well, oh, it's actually right here. I don't have to scroll up that much. Like I said, I'm not gonna lie, I cheated on this one by using SciPy with called linear sum array. So all I have to do is just create a cost matrix and then run this function that does a basically, I don't know if they do, actually, honestly, I don't know if they do Hungarian, but in my mind, I was like, oh, maybe you just need to do Hungarian algorithm, and that's basically the idea. And basically what happens is it just creates a matrix, right? Between, okay, so for each target or the new target, or each in the possibly combined target, for each number in that combined target, what is the cost of matching it with one of the numbers that are in the input, right? And that's basically the idea. And the cost is, of course, the cost it takes to the next multiple, which is this really messy looking thing. And you could just do the math, right? For example, if x is, say, you go to 7 and y is you go to, say, 12, then 12 mod 7 is you go to 5. That's the leftover when you do it. So then to get to the next multiple, you just subtract that from 7, right, to get to 2. So then that means that 14 to get to, 12 to get to 14, you add 2 and you get it to 0. That's basically the idea for this formula. And I do an extra mod as x, just, maybe I could win it differently. It's just that when it is already a multiple like this, then you don't want 7 minus 0, right? You just want to, because it would just be equal to 7, so then you just mod 7 again, is how I did it. You could handle it in other ways. But that's basically how you construct a cost matrix, and I just kind of plug it in. So honestly, it's not, and it's a linear sum, so it's pretty straightforward, pretty fast actually, honestly. But yeah, but still, like I said, is it cheating? Probably a little bit. I mean, not in the contest kind of way, but I definitely cheated myself out of how to solve this. I did actually, if you watch the live portion, I did get this wrong for the first wrong answer, because I just kind of I had a test case in which I kind of misunderstood it a little bit. I think it was something like this is the input 10 9 8 or something like that. The other one doesn't matter, but the reason why it was wrong was that I just had a for loop that took the best, but what happened was that I matched this 10 with this 10 and this 6, the 6s also with the 10 by changing it to 12. So, but of course, if you change this to 12, then this no longer match, right? So yeah, so not the way to do it, but sorry. So that's why I had to kind of step back, think about it, and then yeah. Of course, I also had some silly other typo, but another wrong answer. I have so many wrong answers today. But yeah, but that's basically the idea for this one. Okay, so what is a better idea that isn't quote-unquote cheating with using a library, right? Well, I guess it turns out that you can do this by greedy. As a result of this permutation, we calculate in a way. And I didn't think about this because I was using this part as an abstraction, because I was like, okay, now that we combine everything, I don't have to care about order. But it turns out that because you are doing this permutation thing where order does matter, so we kind of look back at our 1066 as the input. Maybe we, if we kind of do all the permutations, then you have like 6610 as well. But that means that it also gives you an ordering, right? And ordering means that going from left to right, and allows you to kind of brute force trying what match what first in a greedy way. And that's kind of the way to think about it. And what I mean by that is that, okay, let's say again is 8 or 9 8, right? Then here, if this is the target that we kind of permutated on, then you're gonna match the 10 with the 10, get rid of the 10, and then now your 6. In this case, maybe you even combine the 6, right? So your 6 would actually match with the 9 and then get you an answer. And then on a similar note, in the future, you'll want these and maybe the 6 you combine, and then the 6 will match the 10, so that will give it a 12, and then 10 will match the 9, give it a 10, and then you'll find a better answer. But as a result, it actually also brute force every possibility. So that is why it is good, right? Because you're greedy on matching each one. That said, let's try to implement it. So here, maybe I wouldn't to, let's just say we enumerate it, right? And add an I. We can add an I to this. Should make the tuple first. And then we can just sort it, right? And after we sort, then now we can say, yeah. For x in for I in length of cost, right? Then now we take the first element of and maybe like a scene thing, right? So that we don't reuse the same columns. And then what happens is that yeah, so then now for j in cost sub I, right? Actually it's for I guess delta. Oh, no, it's for the C for the cost. Basically, it's this thing, right? For the cell, and then index, right? So for C index in cost, if index is not in scene, then we add it to scene. Total, we add the cost, and then we break, and that's it. And then it'll go to the next I, and that should be good enough, honestly. If you you know if you know Python and don't make silly mistakes like I do anyway. Okay, that is very wrong actually. Why is that? Well, bonus time. All right, let's see. Why what cost will be should be okay. And actually, I guess we could actually do it here, but we don't need to though, so it's fine. But that is weird. All right, let's see. 4 F3. Okay, why? Okay, so cost of why is it not? Oh, whoops. I thought I sorted, but I lied about sorting. Okay, so that now that looks good. Yeah. All right, very silly mistake. Apparently, like I said, I don't know Python. Getting old and tired and in pain. I don't know if this times out, but yeah. So there you go. So that is a little bit cleaner when you rewrite it this way. I mean, not cleaner. I think the other way is pretty clean, but it's just like, you know, you actually solved the problem, unlike me, which I definitely cheated. But yeah, so what's the complexity here, right? Actually, I don't know what is the complexity of. I mean, I know what the complexity of Hungarian, but I'm curious. Let's see. Let's ask ChatGPT. What is the complexity of n cube? That's what I thought. For non-rectangular, it reduces to a square one. Okay. Huh, that's still really fast actually. I guess there are a lot of optimizations because it works for me. But yeah, because that doesn't really make sense necessarily. Because n is very big. I guess they do a lot of optimization things. Maybe even what my for loop does. Let's take a look at the timing real quick. I'm just curious. But yeah, but it's just very brute force, right? So yeah, and the ironic thing is that doing like what we just did is actually much slower and scarier, honestly, right? Like double and a half time more. But yeah. Maybe do the sorting, and actually you don't even need, so okay, there's some complexity things that we can add. So this is 4 factorial times 2 to the third, which is maybe t factorial times, let me write it down, right? T factorial times 2 to the t, right? So that's the old notation. Well, that's just on this part, and then times t on the outside, right? To do a loop, and then what? Maybe that's not it. Well, that gets dominated by this anyway, so we can just do the calculation. So then the calculation is actually, well, in this case it is O of t times n, kind of. Well, in this case it is O of t times n, right? So that's not that bad. But with I don't know. See, that's the thing with complexity. Sometimes is that it lies, and with optimizations when you use library, because this is the thing with Hungarian, right? So so that's a little bit awkward, right? But we can actually and I actually lied here. I forgot that I sort. I was going to get to it because I was going to write. So it's this, right? T times n log n, and that is the algorithm we have here, which somehow is slower than or fast. Yeah, slower than this. But you can actually reduce this to log t, right? Because here, instead of using scene or maybe even using scene, we can. Well, one is that we can combine them, but as a result, we only need to keep track of. You know, instead of, well, let's just rewrite this real quick, right? Let's do a quick, yeah, right? Okay, so this is a quick refactoring. We're doing the same thing so far, but I just want to make sure that I don't have to, because now it is just this, right? So we got rid of the matrix to kind of do the same thing, right? Just doing it one by one. This is a very quick refactor, but you know, in TDD and refactoring way, I just want to see that it works. And yeah, so this looks good. It works. I clicked on accept, and now it takes me here. Still 5.2 seconds, right? So not great, honestly, but faster, like 10% faster, right? From 5.7 or something. And then next thing, right, is well, we know that we only need to, like, we can use a heap is what I'm trying to say, because we only care about I number of items, or maybe not this I, but the number of items that we've seen before, right? Meaning if we've seen no numbers before, then the best number is good. If we've seen one number before, then we only need the best two numbers, and that's it, right? So here we can actually convert this to a heap. And in Python you don't actually, you know, but here you put this here, right? And if length of cost, we want a max heap though, right? Yeah, we want a max heap so that we can remove the max. Okay, so let's actually push the max heap. So length of cost is greater than length of scene plus 1, just in case. No, I mean, I think that's actually exactly right. Then we pop off the max, so then now cost will always have like 2 elements, and then we can just do this, except for now we want it back in the right order, right? So we actually want to reverse, we want to pop, but then the last, and then we want to reverse it, right? So new cost is equal to right, while length of cost is greater than 0, cost dot append heap dot heap pop of cost, right? And then at the end we reverse it, right? And here we do end cost. I think that's right. I mean, maybe I make silly mistakes because I tend to make silly mistakes. Need it to be here. Clearly this is way not right. Oh no, because the cost is whatever, and here I was just lazy, honestly. Yeah, I mean, you could also just write negative C. It's just very yucky, but I just want to show the complexity real quick. But yeah, but as a result, now we reduced it from log n, the search factor, to log c, and yeah, let's see what timing that is. So definitely some optimizations there. That actually didn't change it that much. Actually, kind of a little, but you know, we are doing a couple of crazy things, so maybe that cancels it out. Actually, a little bit surprised though, still, but yeah, okay. I am okay with this. But yeah, that is all I have for this one, and this makes it log t instead of log n, which is a little bit better. But yeah, that is all I have for this one. Let's go over the let's show you the code again. We have here on top to calculate, here on the bottom If you want to see the oh, and here's the header in case you want to know. Maybe that was too fast, sorry. Okay, so this is the top, this is the bottom, and maybe the header. And I just want to show you my original submitted solution, just, I don't know, contest one. And so this is the only thing, right? For Hungarian. But yeah, that is all I have for this one. Let me know what you think. Thanks for watching. And yeah, you can watch me solve a live in the contest now. Things. Okay. Let me double check the running time. That was really silly on me. Today's been a silly day. 4 seconds actually not great, but I think the idea is we just used too much maxmin. We'll come back later for it. Alright, nums and target. Okay. 21 people got it. This one already. And how many people got the Q4? 11. So a lot of people are done, and I'm still on Q3. Alright, let's see. Nums and target. Increment any elements by 1. With 1 multiple in nums. Each target had at least 1 multiple. So okay, 4. That's interesting. 10. We need 8 to be 5. Okay, what does that mean though? Okay. Oh, target only has 4 numbers, so that is maybe interesting. What does 4 number mean? Just choose 4 maybe, but I mean, we could brute force on solving it together. I guess that's how you do it. What is the combination there? Right? I don't know. 4 numbers is easy to brute force. I mean, it's just brute force. Okay. Yeah. It's not 2 to the 4. It's actually like 4 factorial times 2 to the 4 or something like that. Or 2 to the 3, I suppose. Which is not that bad, right? Times 8. Yeah, that's not that bad. Okay, I think that's good. Okay, yeah, that's not that bad. This is a 6th problem. Okay, I just have to write it. How do I do it in? I think Python 2 has other tools for it. Maybe. Other tools, not permutations. Okay. Fine. Okay. Permutations of nums, right? For p in permutations. I think that's fine. Yeah. Okay. I can't believe I messed up Q1. Well, I mean, I could believe it, but it's still very sad. Okay. So then now we do a 2 to the p thing. Okay, right? So then now, yeah, 4. Because there are only 2 to the 3 gaps, and then it's just take the LCM of the 2 of the numbers, right? Nope. If it should be num sub 0, and then if I and 1 no, this is I minus Yeah, okay, this way. This is 0 to 0. It doesn't matter which way it goes. Then we want to append a new number. +1, else we say is equal to LCM of the previous number and this new number, and then that will give us all brute force things. And then now, okay, so we have a best is equal to minimum, right? So infinity. Yes, here. So then now I'm gonna go best is equal to calc of array. Okay, I think that's fine. I was a little bit lazy to do this on the previous problem, and the time on that one is very slow, so that's why I'm doing it. Okay, so then now we have 3 numbers, right? So 3 or 4 numbers, so that's fine. Also, this is wrong. I meant t is equal to, or n is equal to length of target. That's what I meant to do. And then m is equal to length of nums. But we don't even care for that part really. We just want to say for x in array, total is equal to 0. X array, I don't know, best is equal to also infinity. For y in nums, we have so then it is just the next number that the next multiple, right? So it is going to be mod, so y mod x is the leftover, so then the opposite of that, right? So x minus this mod x, right? I think so. Yeah, it's a little bit too much mod, but whatever. Anyway, total I think that's it really. We need to that's not great. Is it because of one number, or like the one number case? Total is 0. Alright, you can take your time on this one, Larry, but why? Tell me why. Away. One. That's not great. It's actually terrible. Oh no, there's only 4, but I am, because I'm putting in nums, that's why. Should be target. But it should, I don't know if that should be what happened though. I was very bad about confusing the 2 arrays, clearly. Okay, so at least that's good. But why? Why is this returning? No, it's here. Oh, it's max. Why did I roll max? Okay, 1, 2, 0. Okay, that looks good. I guess having 4 numbers is the worst case, right? So okay, so then maybe we can just say we do have a 4 number case. It doesn't really matter, I suppose, but why does it matter that this is bigger than that? That's so weird. Do they have to be different? No, right? So I don't get it. Okay. What I wanted to do is just set up like what is it? Reasonable limits, so we're okay maybe. Okay, timing is a little bit slower than I would like, but also okay. So we'll see. Maybe it's too slow. It's unclear because with Leetcode you can never know. You see that for the worst case is fine. Wrong answer is actually unexpected. How can it give me wrong answer? But it is just so brute force. I put 2, but it's unexpected 3. What is the answer that gives me 2? Man, today is just not my good day. Clearly. I thought I would be done, but... Okay, so I'm on the last one. This, I think that will be 30, but 10, 6. 10 and 6 will give me 2. That's what I think, right? Because oh, I see. Oh, that's weird or not good. Because for this, I have to rethink this because I put 10. Because 10, 10, but then the 6 also uses it, so we can't just do it that way. Okay, I see. Wow, I miss that case a lot. Okay, so we're not independent. Alright, now to think about it. How did 40 people get it already? Okay, so that is a good case actually. Very sad that I have to find out this way, but it's okay. Saves me time to figure it out. So then now you have to choose 4 numbers from here, or up to 4 numbers from input. That's hard. I think I'm supposed to take advantage of the fact that the numbers are small though, up to 10,000. So you can do things about it. So you can brute force in that way. But 95 people? Am I just really slow today? I guess so. Huh. I mean, I thought I could do it with brute force, but I could not delineate it. But, which is fine. Okay, let's think. Maybe I just need to fix this part, but I don't know that. Okay, so let's say we take advantage of the fact that it only goes to 10 to the 4. Oh, it's only up to 10,000. That means the answer will always be fine in 40,000, right? That's a good one. Oh, did I lose it? Oh well, by refreshing. I could come up with it, but I forget what it is though. But it's something like 10, 9, 8 or something. But how do I think about this one? Huh. Today's not a good day for Larry. Okay. Sif. Can I do Sif? Sif and slide. Would it be greedy? I guess so, right? So we have the numbers in array. Oh no, it's multiple. So so then you bucket it by that. No, but then you have to figure out how to do it independently, right? So here you have the 10 and the 6, and they have to be independent of each other to handle the 10 and the 9, right? So how do you have to group them? So they're not independent is my point, Larry. Right, so how do you handle that? Well, there are only 4 numbers. Huh. Man, I am just stumped today. Not great, but we have an hour. Maybe I should have rested this one. Max bipartite matching, is that it? Min cut max flow. This is a 6-pointer for min cut max flow. Is there network X in this? I forget how to use network X. Can I do this? Let's see if they have it. I actually don't know if that's a library that Leetcode has. Okay, so I can't use it anyway. That's good. Or maybe that's good. I don't know. But also, I should be able to solve this without it. But I'm just not having a good day. Okay, so this is the case that I'm having issues with. Huh? Because you cannot do them independently. How do I match them? How do I calculate that with a cost of 0? Do I just do Hungarian? Yeah, I don't know. Let's see. So that works, Hungarian. I guess we'll see, but I guess it's just this thing, right? And then how do I use it? Something like that, I think, and then it is just a cost, right? Something like that, maybe? Yeah, that's right, but that's weird. Okay, let's okay, let's try again to see if that is too slow. It may be too slow, honestly, but actually this is so much faster than whatever I had, which is actually ridiculous. Alright, let's YOLO submit. If it times out, I understand. I put 4, but then to 0, which makes sense. Why do I have 4? Man, I'm making a lot of mistakes. I mean, I don't even think Hungarian is necessary, honestly, but still. There should be an 8 and a 10, and then you just have a... Also, I think I can optimize it by doing... I don't know what I'm doing. I'm taking way too long. Just so that I could almost like a memorization. So okay, 840. No, there should be an 810. So I messed up on my brute force, I suppose. There should be a let's see. Why is there no okay, so right? So it should be one of these. Oh, I am dumb. It's just that this is inside the loop, but that also makes things... No, that's right. Huh? Why would it do this so many times then? Oh no, this is P and then an array. Right? Oh, okay. Let's print it out. Did I not print it out? I thought I printed it out. Nope. Okay, so we have 8. That is really awkward, actually. Well, that's why this is wrong, but... Why is there an extra 8 at the end? J plus 1, J plus 1, that's it, right? Huh? Why am I so bad at basic things? If they're all 0... I don't know what's going on. 0, this is not right. Well, maybe that is right. Maybe if I is no, this should be right, right? If it's equal to 0, then you append a new thing. I don't get it. Why am I so bad at this? What is this? Where is this array getting it from? Am I just bad at bitmask? I mean, it shouldn't matter, but I usually do write it the other way. Okay, so 1 means that it has an 8, and then everything else you merge, right? 0 means everything you merge. But what's 4? Why? How can there be an 8 afterwards? 4 is just 0, 0, 1, right? Why am I debugging this? Larry, why? How are you so bad at this? Okay, I mean this, okay, so 8, 2 8s. Okay, so after today, am I off by 1? J plus 1 is right. Right, yeah. Oh, it's not target, it's P. Oh no, that's why. Oh, Larry. Okay. Silly mistake. Can't program. We'll see what the next wrong answer is. Okay, fine. Alright, how many people got this one? 59, so maybe I can make... Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this contest, these problems, and everything in between. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye-bye.